from -7 to 7. Now, anybody got a calc there handy? Would you help? You're gonna have to play with your window. I want you to go from -7 to 7. And graph that. Now, it should look like a power line. And when it should do what? Slightly go like that. It won't be straight. It won't be straight, but you should see a little.
So put that 25.
But for your window, you're gonna have to look from -7 to 7. If you wanna mess with it.
Yeah, that's a good line.
Everyone, let me make a note. X and Y are measured in meters. Now I'm curious, how high did this thing get? Someone's gonna have to tell me the y-intercept. How do you find the y-intercept?
X equals to 0.
So what's 25 times cosh of 0 minus 15? You can do it on a blank screen. You got it, Jess. What's 25 times cosh of 0 minus 15? And remember, Kaylee, you can just hit it on that catalog button, right?
Yeah.
If you want to type it in. What's 25 times cosh of 0 divided 25 minus 15? How high did this curve get up to? Is it 10? So there's the y-intercept. But what did this curve do? Everybody see the graph? Amber, did you get the graph going?
No.
Want me to help you type it in?
Yeah.
We'll go hit that cosh off the catalog.
Yeah, I did -7.
Oh, good call. So you did 25, now we'll get what? Catalog. You want to jump to the C's real quick? See how I got there real quick? Isn't that cool? I didn't like scrolling the whole time. Where's cosh? There it is. All right, 25 cosh. X divided by 25. Common question I get from my online students. Where's the cosh on the calculator? You know, where are the hyperbolic trig functions? Or the hyperbolic functions? Then we hit graph. You know, we can't see it, so any suggestions on our window?
I did 20 for Y.
What'd you do for, what was your low?
I just kept it at 10.
Yeah, that's cool. We can make the y min like 0.
Yeah.
Y max, how high would you go?
20.
20. Let's see how low.
Actually, you can do it in 15 too.
I like it. Oh, there it goes. If you didn't want to go so high, we could have gone to what? We made our y min 0. If anybody wanted to make the y min 0, your y min was fine though. And she did y max 20, that's fine. We could have done what? Just as long as you get over 10, maybe 15 or something. Will that work? Oh, there it goes. Like a power line, right? So what's going on with this problem? They said, here's the function, but it's tied between two poles at these locations. So there's a pole right here. All right, and these are poles right out of the ground. So there's the poles, this is a pole, this is a pole. But this represents the what? This represents the catenary. They call this a catenary. There's the catenary. Cool. Now here comes the question. Everyone, could you find the slope of the curve when it meets the right pole? You find the slope of the curve. That means slope of the tangent line drawn through the curve. When it meets which pole?
Right pole.
Yep, when it meets the right pole. I like this. And if we're only allotted a little time out of the course syllabus in terms of the outline time frame, they just spend like a half hour in a section. Okay, we'll hit hyperbolic sine, we'll hit hyperbolic cosine, we'll know about their derivatives, and we'll do an application problem. Okay? It's kind of fun. So we're going to find the slope of the curve when it reaches the, I'll just put it, find the slope of the curve when it meets the right pole. All right. How do we find slope of tangent lines in calculus?
Take the derivative of the original function.
So we're saying, everyone, to answer this question, we're going to take the derivative of this function,
Mm-hmm.
and then we're going to substitute what value?
7.
7.
7 agree? That's what we're gonna do. Good problem solvers. I like it. Take the derivative of this, plug in what?
So it'll be negative.
7.
So it'll be 20. No.
Be careful though, we're gonna have to do show what rule.
Chain rule.
Chain.
Alright, first of all, what is, before I start, what's the derivative? Because you have to know this, like even on your test. What's the derivative of cosh? Right?
Sine.
Is it negative hyperbolic sine or is it positive?
Positive.
Negative.
Because it's positive. I know. Don't think trig. I know it behaves like trig, but the cool thing about hyperbolic sine and hyperbolic cosine, right? Each one has the other derivative, but there's no negatives. So real quick, derivative of this is just what?
Sine.
Yep. And what's the derivative of sine x?
Cosine.
Cosh x, right? If you get tired of saying, don't you? You'll get tired of going
Yeah.
hyperbolic sine, hyperbolic cosine. So you call it cosh, but I don't know what you want to call that one. I've asked colleagues and they go, I just say hyperbolic sine. Because it's hard to say sine,
Or sin HX.
sine hx, right? True? Hey, if you did an SCSCS on this thing, what would it look like? There would be no what here?
All
No
positive.
negatives.
No negatives. So when you're in differential equations, maybe a semester or two from now, and you have to take the antiderivative of one of these, it's just gonna be that, right? You just go that way. Does that make sense? Alright, so we're gonna do derivative. Now what's the derivative of the constant?
0.
Alright, so that's 0, and don't put that minus 15 in there. Here we go. We're gonna get y prime, and then we're gonna substitute what number?
7.
7. Alright, here we go. What's y prime of x? We get,
Hyperbolic sine.
alright, 25, constant stays in front. Hyperbolic sine. Amber, no negative, right?
Yeah,
No negative. X over what? 25? Maybe another way I'll write this, because it helps you see it. Isn't that just 1/25 of an x? Maybe I'll write it that way. Because I have to do chain rule right now. Right? 25 sine, there's my g. And what do I always multiply with chain rule? G prime, right? And if that's g, what's g prime? Here comes the chain rule, right? Chain rule, there's my g. What's g prime? What's the derivative of all that? It's right there.
X.
1/25. Right, everyone? Here comes g prime right away. Multiply to all this. 1/25. You see that? Are you okay with that, Amber?
Wait, what did you do?
All right,
Oh,
fine.
you just got rid of the x.
Because this isn't this like my g?
Yeah.
So hey, when you're doing this like on a test, you do all that, like sine of 2x, you go, oh, the derivative. Cosine 2x times 2. And that's that chain rule. The g prime was the derivative of that 2x. Same thing here. We know that right there, but we have to apply chain rule here. And you're like, okay, I gotta multiply this. And a lot of you put this where? Up here?
Yeah.
I think it's a good idea. Well, let's move that there.
Which is just 1.
She goes, you're just gonna get 1. So here, I'll drop this down. Amber, that was good. She goes, hey everyone, this 25 and that 1/25 are just gonna what? So I'll write it again, and then we're just gonna substitute what into our calculator.
7.
Alright. Now I'm gonna write it back like this, because it looks easier to type it on the calculator. Alright, that's it? So I gotta plug in what number?
7.
So what's the slope of the tangent line? Hey, Josephine, real quick, before I answer your question, why do a lot of online students leave an answer like that? You go, why not? Because they don't know where that is on the what?
Calculator.
Calculator. We'll hit it. We'll get the number. We'll get the decimal reading. Go ahead, Josephine.
Get the 7. Because I don't have a pad.
Oh, that was the question posed. It was just asked. That was the question asked, right?
Oh, you did.
They put the sevens, the 2 poles, and the question was, find the slope of the tangent line at 7. I know. Or actually, you know what they said? Look at this. They said when it meets the right pole, Josephine, put this down. But they did mention there were 2 poles located at these locations.
Oh, okay.
They even drew an image. Josephine, they drew a picture to help you see there's a pole right there. And there was a 7. Oh yeah! It's all, I like to go to catalog. I'm sure there's other menus you can find this stuff. But you forget the menu. We always know catalogs. So I'm just gonna go, ready? I won't even graph it. We'll just do the value now. See catalog, second 0, second 0. Starts at
Oh, so
A.
we're
We
not-
wanna get down to what, S? I could scroll forever, it takes her all, let's just hit the S, where is it? Right there? No, I'm at S. Hey, does anybody know how to quickly get to S in catalog?
Click on S.
She goes, click on S, Sarah, thank you. She goes, after you hit catalog, find the S on the front screen, and you'll get the S's quicker. That's not it? There it is. Now what do we gotta put in there? 7 over what? Do you have to be in radio mode?
No.
No! People think you don't have to be in radio mode. Alright, what is it? Tell me the answer.
0.28.
And when y'all getting about 0.28,
Yeah.
That's it?
that's the slope, that'd be the slope, right here. That'd be slope of that curve. That's important. I don't hang power lines or anything like that, right? Or telephone lines. A lot of times they got them under the ground now, right? But that slope is actually important to the person what? Designing it. They have a specific slope in mind that they want. This is about 0.28. What was that, 85?
Is there no units?
Point.
284. Alright, well, thank you.
Is it in meters?
Oh,
Yeah.
yeah,
Meters.
that's right. That's exactly it. Everyone, great job. Are you ready for 4.1? I know, they didn't want to spend too much time in that section.
Can we still have to find the angle?
Good question. You can if you want. On a test, I don't ask you for that. Right? But you could find the what? Yeah, now if you said, how would I do that? You could build a little triangle here. And you could think, all right, if I went 1 in this direction, and you have this, you could do like a trig ratio there, couldn't you? Do you see that?
Yeah.
You'd be like, oh, okay, the slope of this tangent line, rise over 1. And what if you're curious how to get the angle? I'm just gonna draw a tangent line like that. And on purpose, I'm just gonna make this a 1. If you wanted to find the angle, wouldn't the rise be the 0.285?
Mm-hmm.
Because the slope of tangent line, rise over run of that line right there. And then to get this angle, you can do a inverse tangent.
Oh, okay, good.
You could inverse tan that ratio there and you could get the angle. But Ben, I don't do it. If anybody's curious, I don't. But I want to make sure you knew how to do it. You go, I can inverse tan that thing and I can get the actual angle right there of what's going on there. Because sometimes they use that too. They want to know the angle that it's coming at. Cool. All right. Hyperbolic functions, cosh, and sine h. So yeah, this is what's going to happen. It's going to be a year from now. And you're going to be like a differential equations course, and all of a sudden you're going to have to find the derivative of this guy. And someone probably next to you in your class is going to go, what the heck is that? And that calc teacher probably skipped over the section. You know, you probably hit a snow day and they just looked at something to what? Remove, no, I'm not doing the hyperbolic functions. But you'll know that derivative is just what?
Cosh.
Cosh, right? And what's the derivative of cosh?
Sine.
Yep, sine hx or hyperbolic sine.
Now, did they derive this from the exponential functions? That's how they did derive it?
I know,
That's how they did?
yeah.
Oh, okay.
But you say, isn't that cool when we did, we did the derivative of that, we're like, we came right to the other one.
Hmm.
But that's how they did the same thing when they were looking at it, and they're like, all right, let's just, since they behave like the derivatives behave like the trig functions, we'll just call them hyperbolic sine and hyperbolic cosine.
Hmm.
But you don't have to be in radio mode, right? Cool. All right, everyone, 4.1. What's in this section? Max and mins.
Is it like the relative max, relative mean, and like the?
Amber's already ahead of us, Ellen. She knows all about this. That's good. How do you know this stuff?
I think it was.
Is this a minus b over 2a?
I love it.
I forgot what max it was.
Pretty good, Amber. What are we doing now? We're going to see the applications. This will probably go from section 4.1 to 4.3, but you might have graphs like this, right? But right here, something interesting is going on with the slope of this curve here. Let's call it up. What's the slope right there?
0.
So we're like, oh, okay, f prime equals 0. And we can call this a max.
Uh-huh.
But who knows? This graph might have gotten even higher. I'll just do that. So it's not the absolute max. What could we call it?
Relative.
Relative max. So we can call that a relative maximum. Relative to this area, relative to this vicinity. They also call it a local max. So local maximum, what can we call that point?
Local mean.
A local min or a relative min. What can I call that?
Local max.
Local max, here, let me make that smooth, sorry. And then it just took off. I hope I kept it as a function, I hope I kept left to right there. There we go. Local min, local max, what's the slopes at all those points?
0.
Slope of tangent line of curve, 0. So, when it comes to finding max and mins, we know what to do now. Get the derivative, and set it equal to what number?
0.
0. Cool. And I'll get you a sheet that kind of summarizes all this stuff. We'll get into it, in a second. But very good with that. Are some functions having absolute maxes and absolute mins?
Yeah.
The word absolute means the absolute, right?
Absolute value.
I don't think this one did, if I went like that, true? But who's got some examples of a graph that had an absolute max or min? X squared. I love it. And he just came up with a simple example. This graph has an absolute what? Right there, what's going on?
That's the
It's not only a local min, that's the absolute what?
Min.
Absolute min. So some do have absolute mins. What else?
X.
I like this, Ellen. That's a great example. Did you hear
What's
this?
the difference between a local min and a relative max or min?
They're
They're the
the
same
same thing.
thing. Remember that? I mean, you can write that down.
Same word.
Local min, relative min, they mean the same thing.
What
So
about,
vice versa, local, relative, and then sometimes they
And then
switch
there's the-
between them.
Yeah, and then with the relative min, there's like an absolute rate. Yeah.
Well, now the word absolute,
It's like the
that's
highest-
totally different, you know?
There's like the
You're saying a
highest-
relative could be absolute, yeah, but
But absolute.
here's
one
an
is-
example. It's the absolute lowest point, right?
Yeah.
There you go. So that's an absolute min. He said, could I call it a relative min? Well, sure, I mean, relative to that, but it is the absolute min.